Hi and welcome to Section 2, an introduction to basics of OpenCV. In this section, we will discuss how to read, write images and videos in OpenCV, and also see how to build a project using CMake. We will learn configuring projects with CMake, reading and writing images from and to disk, reading videos and accessing camera devices, the main image structures, matrices, other important and basic structures, vectors, scalars, and so on, basic matrix operations, file storage operations with the XML YAML persistence OpenCV API. Now we move on to the first video of this section that deals with basic CMake configuration and creating a library. In this video, we are going to take a look at CMakeLists.txt file and use add library function. To configure and check all the required dependencies of our project, we are going to use CMake, but it is not mandatory. So we can configure our project in any other tool or IDE such as Makefiles or Visual Studio. However, CMake is the most portable way to configure multiple platform C++ projects. CMake uses configuration files called CMakeList.txt, where the compilation and dependency processes are defined. Let's have a look at CMakeList.txt file. Here we are going to the directory. You can build your project in any of the directory of your choice. Here we created a test folder, and this is the file. Open this file. I'm using Atom Text Editor. You may use Notepad if you want to. This is the code. The CMake line defines the minimum version of CMake required. This line is and allows you to use the CMake functionality defined from a given version defined. In the second line, it defines the project name. This name is saved in a variable called project_name. The last line creates an executable command in the main CPP file, gives it the same name as our project, and compiles our source code into an executable called CMakeTest, which we set as the project name. The $ expression allows access to any variable defined in our environment. Then, we can use the $ project_name variables as an executable output name. CMake allows you to create libraries which are indeed used by the OpenCV build system. Factorizing the shared code among multiple applications is a common and useful practice in software development. In big applications, or when the common code is shared in multiple applications, this practice is very useful. In this case, we do not create a binary executable. Instead, we create a compiled file that includes all the functions, classes, and so on developed. We can then share this library file with the other applications without sharing our source code. Let's see the basic CMake functions. The lines starting with #add comments and are ignored by CMake. These are comments. The add_library hello.cpp hello.h command defines our new library called where hello is library name and hello.cpp hello.h are the source files. We add the header file to allow IDEs, such as Visual Studio, to link to the header files. The line we generate are shared file, so for OCX and Unix, or .dll for Windows, or a static library, for OCX in Unix, or .dll for Windows, depending on our operating system, or if it's a dynamic or static library. This is the function that links our executable to the desired library. In our case, it's the hello library. Cool. In this video, we have looked at CMakeLists.txt file and used add library function. Great!